Imagine looking through a powerful telescope one silent night, discovering a distant planet that refuses to keep a stable form, slowly stretching, shrinking, and twisting like a cosmic sculpture. Astronomers once believed planets were solid worlds with predictable shapes, yet recent discoveries suggest that somewhere deep in space, a mysterious world constantly changes its physical structure. This strange planet does not behave like Earth, Mars, or Jupiter because its entire body responds to powerful gravitational forces that squeeze and stretch it every single moment. Scientists observing distant star systems noticed unusual signals, small variations in brightness and motion, hinting that something extraordinary was happening on a world orbiting extremely close to its star. At first, researchers thought their instruments were malfunctioning because the planet appeared round during one observation but slightly distorted during the next measurement only hours later. The deeper scientists studied the data, the more astonishing the conclusion became, revealing that the planet was literally changing its shape as it traveled along its orbit. This bizarre transformation happens because the planet lives dangerously close to a massive star whose immense gravity pulls strongly on one side of the planet. That gravitational pull stretches the planet outward, creating a shape that resembles an elongated oval rather than the perfect sphere we usually imagine when thinking about planets. When the planet moves slightly farther along its orbit, the pressure changes again, causing the world to compress and shift, almost like a living object breathing slowly in space. Such a dramatic effect is known as tidal distortion, a phenomenon where gravity from a nearby star or massive object stretches another celestial body into unusual forms. While Earth also experiences tidal forces from the Moon, the effect here is incredibly stronger, powerful enough to reshape an entire planet again and again. The constant stretching produces enormous internal friction inside the planet, generating tremendous heat that may melt large portions of its interior layers. Because of this intense heat, scientists believe the surface of this world could be covered with rivers of molten rock rather than oceans of water. If someone could stand there, which is nearly impossible, the ground beneath their feet might slowly shift as the entire planet subtly changes shape. Even the planet's gravity would feel strange, because the uneven form would create slightly different gravitational pulls depending on where someone stood. This means that walking across the surface could feel unpredictable, almost like gravity itself was bending along with the planet's distorted body. The discovery of such a world forced astronomers to rethink long-held assumptions about how stable and uniform planets are across the universe. For centuries, scientists imagined planets forming into nearly perfect spheres due to gravity pulling material evenly toward the center. However, this unusual planet demonstrates that powerful external forces can disrupt that balance, reshaping entire worlds in ways previously thought impossible. The star system containing this strange world lies incredibly far from Earth, many light-years away, making direct observation extremely challenging. Despite this distance, advanced space telescopes are capable of detecting tiny changes in starlight as the planet passes in front of its star. These changes reveal not only the planet's size, but also subtle clues about its shape and how that shape shifts over time. Each time the planet completes an orbit, astronomers notice slight variations in the shadow it casts across the face of its star. Those variations provide evidence that the planet's form is not perfectly round, but stretched by intense gravitational forces. Computer simulations later confirmed that such distortions are possible when a planet orbits extremely close to a massive star. In these simulations, the planet becomes elongated, almost like a teardrop pointing toward the star that dominates its gravitational environment. One side of the planet permanently faces the star, constantly heated by intense radiation and gravitational pressure. The opposite side remains relatively cooler, but still experiences massive internal stress caused by the continuous stretching of planetary material. Over millions of years, this gravitational tug-of-war may slowly change the internal structure of the planet itself. Some scientists even believe the world could eventually lose pieces of its outer layers, pulled away by the overwhelming gravity of the nearby star. If that happens, streams of planetary material might drift into space, forming glowing trails similar to the tails seen behind comets. These glowing streams could create a spectacular cosmic display, visible to distant observers studying the star system with powerful telescopes. The moment astronomers confirmed the existence of a shape-changing planet, curiosity spread rapidly through the scientific community because such a discovery challenged many fundamental assumptions about planetary stability. Researchers immediately began searching for known exoplanets that orbit extremely close to their stars, since intense stellar gravity is the main force capable of distorting an entire world. Among the many distant candidates discovered by modern telescopes, a few planets stood out because their orbits were unbelievably tight, placing them dangerously close to their blazing host stars. These planets are often called ultra-hot worlds, where temperatures soar high enough to melt metals and transform solid rock into flowing rivers of glowing lava. In such extreme environments, gravity does not merely hold the planet together, it constantly pulls, stretches, and compresses the entire world like cosmic clay. One of the most fascinating discoveries involved a distant exoplanet whose orbit is so close to its star that a single year there lasts only a few hours. This incredibly short orbit exposes the planet to relentless gravitational stress, forcing its entire structure to adjust continuously as it circles its star. Scientists studying its light patterns noticed that the planet's silhouette against the star appeared slightly stretched rather than perfectly round. That unusual observation sparked deeper investigation, leading researchers to model how gravity might reshape a planet under such extreme conditions. Computer simulations revealed that when a planet moves extremely close to a massive star, the gravitational pull becomes uneven across the planet's body. The side facing the star experiences a stronger pull, while the far side feels a weaker force, causing the entire planet to stretch outward. This stretching gradually transforms the planet from a sphere into a shape resembling an elongated egg or a cosmic teardrop. The effect is called tidal deformation, a phenomenon well known in astronomy but rarely observed on such dramatic planetary scales. Even in our own solar system, our tidal forces shape moons and planets, though the distortions are usually far too small for us to notice. Earth's oceans rise and fall because of tidal forces created by the moon, yet the solid body of Earth barely changes shape. On this distant planet, however, tidal forces are so powerful that the entire world flexes under gravitational pressure. Imagine squeezing a rubber ball repeatedly while it spins rapidly, and you begin to understand the constant stress this planet experiences. Each orbit becomes a cycle of stretching and partial relaxation, forcing the planet's interior to shift and generate enormous heat. This heating process is known as tidal heating, and it can produce intense volcanic activity across the planet's surface. Some scientists believe that gigantic volcanoes may erupt continuously there, pouring lava across landscapes already glowing with extreme temperatures. The atmosphere of such a planet, if it exists at all, would likely be filled with vaporized rock and scorching gases. Powerful stellar radiation would blast the surface constantly, stripping away lighter elements and leaving behind dense mineral clouds. In some cases, material escaping from the planet might form glowing rings or trails stretching behind it in space. These glowing streams could make the planet appear as though it is slowly dissolving while orbiting its star. Yet despite losing material, the planet continues enduring immense gravitational stretching with every orbit it completes. Astronomers believe this process may last millions of years before the planet eventually breaks apart or becomes significantly smaller. Such dramatic planetary evolution shows how powerful stars can reshape and even destroy the worlds that orbit them too closely. Some researchers compare these planets to cosmic experiments demonstrating what happens when gravity pushes matter to its limits. Observing them allows scientists to test theories about planetary formation, internal structure, and the long-term stability of distant worlds. Advanced telescopes like space-based observatories detect these planets by carefully measuring tiny dips in starlight. When a planet passes in front of its star, the star appears slightly dimmer for a short period of time. By analyzing these dips repeatedly, astronomers can estimate the planet's size, orbit, and sometimes even hints about its shape. If the planet were perfectly round, the dimming pattern would remain consistent every time it crossed the star. But a distorted planet produces subtle variations in that pattern, revealing its stretched structure to careful observers. These variations may seem tiny, but with modern instruments, scientists can detect changes smaller than a fraction of a percent. Such precision has opened an entirely new era in astronomy, allowing researchers to explore distant worlds in unprecedented detail. As astronomers continued studying strange planetary signals, several real exoplanets emerged as prime examples of worlds experiencing extreme gravitational distortion near their powerful host stars. One famous candidate is an ultra-hot exoplanet located hundreds of light-years away, orbiting so closely to its star that its entire structure is constantly pulled into an elongated shape. Scientists believe this planet experiences tidal forces thousands of times stronger than those affecting planets in our solar system. Because of these forces, the planet's structure may resemble a stretched oval rather than a smooth and perfectly round sphere. Observations suggest that one side of the planet permanently faces the star, locked in position by intense gravitational forces. This phenomenon is known as tidal locking, where a planet's rotation becomes synchronized with its orbital period. As a result, one hemisphere experiences eternal daylight, while the opposite side remains trapped in permanent darkness. On the star-facing side, temperatures could rise beyond 2,000 degrees Celsius, hot enough to melt iron and vaporize rock. Meanwhile, the darker side might still be extremely hot, but slightly cooler due to reduced stellar radiation. The temperature difference between these two sides may generate violent atmospheric winds racing across the planet's surface. Some models predict winds moving faster than several thousand kilometers per hour across the glowing landscape. These winds could carry vaporized minerals through the atmosphere, creating clouds made of exotic materials rather than water droplets. In certain cases, scientists believe molten rock could evaporate and later condense as strange mineral rain. Imagine a sky where droplets of liquid rock fall onto rivers of glowing lava below. Such bizarre conditions make these planets some of the most hostile environments discovered in the universe. Yet their extreme nature provides valuable insight into how planetary materials behave under enormous pressure and heat. Another fascinating discovery involves planets that orbit so close to their stars that they begin slowly losing their outer layers. Stellar radiation and gravity pull material away from the planet, forming long tails of dust and gas trailing behind them. These tails resemble the glowing tails of comets, but can stretch for millions of kilometers through space. Astronomers have observed such tails using sensitive telescopes capable of detecting faint clouds of escaping planetary debris. In some cases, the escaping material forms a giant halo around the star as the planet continues orbiting within it. Over time, this slow erosion could significantly shrink the planet, transforming it from a large world into a much smaller remnant. The process may take millions or even billions of years, depending on the planet's size and distance from its star. During this long transformation, tidal forces continue distorting the planet's shape as it travels through its orbit. The combined effects of gravity, heat, and radiation create a constantly changing planetary environment. These discoveries became possible largely because of advanced space telescopes designed specifically to hunt for exoplanets. One powerful method involves observing slight dips in a star's brightness when a planet crosses directly in front of it. This method, known as the transit technique, allows astronomers to detect planets that cannot be seen directly. By carefully measuring the depth and shape of the dimming, scientists can estimate the planet's size and orbital characteristics. If the planet's shape is distorted, the dimming pattern may differ slightly from what scientists expect from a perfectly round object. These subtle differences can reveal whether a planet might be stretched by gravitational forces. Detecting such tiny changes requires extremely sensitive instruments and careful analysis of massive amounts of data. Modern observatories can monitor thousands of stars simultaneously, searching for the smallest signs of planetary movement. Each successful detection expands our growing catalog of worlds beyond our solar system. Today, astronomers have confirmed the existence of thousands of exoplanets scattered throughout the Milky Way galaxy. Among them are gas giants larger than Jupiter, rocky planets similar to Earth, and extremely exotic worlds unlike anything imagined before. Some planets orbit two stars instead of one, creating complex gravitational environments. Others drift freely through space after being ejected from their original star systems. And a few rare worlds orbit so closely to their stars that gravity stretches them into strange and unstable shapes. These distorted planets challenge traditional theories of planetary stability and long-term survival. Researchers continue building computer models to simulate how such worlds evolve over time. These models help scientists predict the longer scientists studied these distorted worlds, the more they realized that shape-changing planets may not remain stable forever under the relentless grip of their nearby stars. Gravity may stretch a planet repeatedly for millions of years, but eventually the stress could become so intense that the planet's structure begins to weaken. Deep inside the planet, enormous pressure builds as layers of rock and metal constantly shift under tidal forces. This continuous movement generates tremendous internal heat, sometimes hotter than the heat produced during the planet's original formation. The heated interior may melt large portions of the planet, turning once solid rock into vast underground oceans of magma. These molten layers slowly circulate through the planet's interior, carrying heat toward the surface in powerful geological currents. As the crust weakens from below, massive cracks can begin forming across the planet's surface. These fractures may stretch for thousands of kilometers, glowing with lava that erupts from deep within the planet. Each orbit around the star pulls the planet slightly harder, widening these cracks and reshaping the world again. Over time, the constant gravitational stress may cause entire sections of the crust to collapse or sink into the molten interior. Some regions of the planet could experience enormous tidal bulges where the surface rises higher than surrounding areas. These bulges slowly move as the planet orbits, creating enormous waves of solid rock shifting across the planet. The result is a landscape that never truly remains stable for very long. Mountains could rise and crumble within relatively short cosmic periods due to intense gravitational stretching. Lava plains might expand across the surface, reshaping entire continents of rock within thousands of years. In extreme cases, the star's gravity may begin pulling away pieces of the planet itself. When this happens, fragments of rock and dust escape into space, drifting along the planet's orbital path. These fragments can form long glowing streams that trail behind the planet like a comet's tail. From a distance, the planet might appear surrounded by a cloud of debris, slowly evaporating into space. Astronomers have already detected several planets that appear to be losing their outer layers in this dramatic way. Some of these planets may eventually shrink significantly as more material escapes their weakened gravitational grip. Others might lose enough mass that their internal balance collapses completely. If that happens, the planet could break apart into multiple fragments orbiting the star separately. These fragments might collide with each other, forming rings of debris similar to those surrounding Saturn. Over time, these rings could either fall into the star or spread outward into space. In rare cases, remaining fragments might gather together again to form smaller rocky bodies. This chaotic transformation shows how dynamic and unpredictable planetary systems can truly be. Planets are often imagined as permanent and stable worlds, lasting billions of years. However, extreme gravitational environments reveal that some planets live far more dangerous cosmic lives. Their existence becomes a constant battle between internal strength and external gravitational forces. Scientists studying these systems hope to understand exactly how long such planets can survive. Computer simulations suggest that some distorted planets might endure for millions of years despite the immense stress. Others may face much shorter lifespans before their structures collapse entirely. These outcomes depend on many factors, including the planet's size, composition, and exact distance from its star. Larger planets with stronger gravity may resist tidal destruction longer than smaller rocky worlds. However, even massive planets can eventually be torn apart if they orbit too closely to extremely powerful stars. This process of planetary destruction is sometimes called tidal disruption. During tidal disruption, gravitational forces literally pull a celestial body apart piece by piece. Similar processes can occur when stars pass too close to black holes or other massive cosmic objects. Observing these events helps scientists better understand how gravity shapes the universe on massive scales. By studying planets that slowly break apart, researchers gain clues about the limits of planetary survival. These clues also help explain why certain star systems contain fewer close-orbiting planets than expected. Some of those missing planets may have existed long ago before being destroyed by tidal forces. Their remnants might now exist only as scattered dust clouds orbiting their stars. Every piece of debris drifting through those systems carries the story of a planet that once existed. For astronomers, discovering such evidence is like uncovering the fossil remains of ancient cosmic worlds. These discoveries reveal the dynamic and sometimes violent nature of planetary evolution throughout the universe. The idea that a planet can stretch, twist, and slowly change its shape forces us to rethink everything we once believed about how stable and permanent planetary worlds truly are. For centuries, humanity imagined planets as calm cosmic spheres quietly orbiting their stars, unchanged for billions of years within predictable and orderly solar systems across the universe. Yet modern astronomy reveals a far more dramatic reality, where gravity, heat, and radiation constantly reshape entire worlds in ways that challenge imagination. Some planets survive these forces for millions of years, enduring endless stretching and compression as they orbit dangerously close to powerful stars. Others slowly lose their atmospheres, their surfaces, and eventually their very existence as stellar gravity pulls them apart piece by piece. These extraordinary worlds demonstrate that planets are not always peaceful environments, but can instead become extreme laboratories of cosmic physics. Inside such planets, unimaginable pressure and heat transform rock and metal into flowing oceans of molten material. These molten interiors shift constantly, redistributing mass, while the planet struggles to maintain its structure against the star's relentless pull. The constant distortion creates enormous internal stress, causing volcanic eruptions and geological activity across vast regions of the planet. From space, these violent worlds might glow brightly as lava fields reflect the intense radiation of their nearby stars. Astronomers studying distant star systems often feel as if they are witnessing a slow cosmic drama unfolding over millions of years. Each strange signal from a distant star may reveal the presence of another unusual world experiencing forces far beyond those found in our solar system. These discoveries expand our understanding of how diverse and unpredictable planetary systems truly are across the Milky Way galaxy. Instead of uniform and stable worlds, the universe may contain countless planets, living under extreme and constantly changing conditions. Some may orbit multiple stars, while others travel through space without any star at all. A few rare planets may spend their entire existence being stretched and reshaped by intense gravitational forces. The discovery of such planets raises fascinating questions about how many strange worlds remain hidden in distant corners of the universe. With billions of stars scattered across the galaxy, the possibilities for unusual planetary environments are almost limitless. Each improvement in telescope technology increases our ability to detect these distant and mysterious worlds. Powerful observatories in space can now measure incredibly small changes in starlight caused by orbiting planets. These tiny signals allow scientists to estimate the size, orbit, and sometimes even the atmospheric composition of distant exoplanets. In the future, new telescopes may provide images detailed enough to reveal the actual shapes of some distorted planets. Seeing a stretched or teardrop-shaped world directly would be one of the most astonishing achievements in modern astronomy. Such observations would confirm that planets can truly behave like flexible cosmic objects under extreme gravitational influence. The study of these worlds also helps scientists understand how solar systems evolve over long periods of time. Planetary destruction, migration, and distortion may be far more common than astronomers once believed. Some star systems may have once contained many planets that were later destroyed by tidal forces. The remaining planets we observe today could be only the survivors of earlier cosmic turmoil. Understanding this process helps explain the incredible variety of planetary systems discovered throughout the galaxy. Some systems appear calm and stable, while others seem chaotic and constantly changing. The shape-changing planet represents one of the most dramatic examples of how powerful gravity can sculpt celestial bodies. Its existence reminds us that even something as massive as a planet can become vulnerable under the right cosmic conditions. This realization deepens our appreciation for the delicate balance that allows Earth to remain stable and habitable. Our planet orbits at a safe distance from the Sun, where gravitational forces remain relatively gentle and predictable. Without that balance, Earth itself might have experienced far more violent geological and structural changes. Studying extreme planets, therefore, helps scientists understand the rare conditions that make life possible. It shows that stable environments like Earth may actually be uncommon in the vast universe. Yet the same universe that produces hostile worlds also creates breathtaking cosmic wonders. Planets stretched by gravity, stars tearing worlds apart, and glowing rivers of lava flowing across alien landscapes all reveal nature's incredible creativity. Every discovery expands human,